Okay, good evening, everyone. Can you hear me, please?
Good
Good day,
evening. We
sir.
can hear you.
Sir.
Happy Sunday.
Babe, please let me reduce that. Let me reduce the TV.
Welcome to this class this evening. Can you all see my screen?
Yes, we can see it.
Yes, we can see
Oh,
your
okay,
screen.
good, good. Okay, good evening once again. Tonight we are starting from where we stopped. If you recall, we started with descriptive statistics. What is statistics? Statistics is divided into two, in which we have descriptive statistics and inferential statistics. So we've talked about descriptive statistics. Then we started inferential statistics like 2 days ago. In inferential statistics, we talked about, inferential statistics is divided into two. We have the estimation and test of hypothesis. So under the estimation of this of inferential statistics, we have point estimate and interval estimate. We talked about the point estimate. We also talked about the interval estimate, in which we calculate the 95% confidence interval. We check other things under the interval estimate. Then we proceed to testing of hypothesis. Under the test of hypothesis, we talked about the variable classification. We talked about how we can choose our test. We talk about the criteria for choosing test. And then we talk about when we have a large sample and when we have a small sample. We talked about when we have a large sample means that our n is greater than or equals to 30. And then when we have a small sample, it means that our n is less than 30. We also talk about the two errors that we have in statistics. We talk about the type 1 error and the type 2 error. That the type 1 error is the error when you reject the non-hypothesis when it is true. And then the type 2 error is when you accept the non-hypothesis when it is false. And we also talked about the power of the test, which is the correction for type 2 error. We proceed by we started with the Z test. Then we will talk about the one sample Z test. We talk about the two. We also talked about proportional test, in which we dwell more on the proportion, because the only test that can handle proportion is the Z test. And then when we're talking about proportion, we'll be talking about the prevalence. Oh, what is the prevalence of disease in this population? What is the prevalence of disease? What is the prevalence of the disease outbreak? So we use proportion for that. Furthermore, we moved to t-test. Now, under the t-test, we talked about we have three types of t-test. We have one sample t-test. We have dependent t-test or peer t-test. Another name for dependent t-test is peer t-test. Then we we made some calculation on one sample t-test, and then we stopped at dependent or peer t-test, in which I gave some assignment that you should send it to my DM or you should send it to the group. But it's just a few people that sent it to me, and I've confirmed that. Please and please, statistics is something that you keep on working. You keep on working. It's not like our normal theory that we read. Once we read it, then we can leave it. So, but statistics, you keep working it. You keep working it. And the reason why I gave that the other time is that I don't want a situation whereby I'm the only one solving it. It should not look like it is easy. It is easy. Yes, it is easy when we are solving it together, but when you try it on your own, you will know, oh, this area I did not get it very well. You will quickly reach out to me so that I can explain further. And for those people that send their work to me, I've answered some, I've not answered some. I'm still going to answer that because I have a lot of work. I have to be preparing this slide every day. So pardon me for that. So now on that, we are continuing today and we are moving to what we call two sample independent, two independent, to the sample size must be small. What did I say? Once you have your end less than 30, then you are going to, that is number one. Then the second part that you are going to consider is when your population variance is unknown. Immediately you discover that in that question you are not given a population variance and your sample size is less than 30, that means that you can use T test. So now, what is the criteria? Oh, if I see this one, I know that this is one sample T test, this is dependency test, and this is two sample independent T test. We talked about the one sample T test that, oh, immediately you are given one group. If you are considering one group, for example, oh, I have a set of people, oh, they are complaining about the headache, and I have the drug that if I give it to them, it will heal their headache in the next 5 minutes or in the next 1 hour. Oh, I'm giving them the drug, just a single group of people. So in that case, if I want to measure the potency of that drug, we are going to use one sample T test. Now, the dependent T test is, oh, when we have the pre-test and post-test. For instance, oh, I have a set of people with high blood pressure, and there is a particular drug that is a particular company has developed that can bring down the high blood pressure to the normal. Before I give them that drug, I take the reading of their blood pressure. We have a record for that. Then after giving them that drug, maybe after 7 hours, we still take the reading again. It's still the same set of people. Nothing changed. We don't have any set. We don't have another group. So the same set of people we performed before and after. So in a situation whereby you have that before the experiment, before you give them the intervention, then after you give them the intervention, and you want to measure, I want to check, oh, how potency, how effective is this drug or vaccine, then we use what we call dependent or peer test. But in the case of independent two sample test, that means that number one, the two, you must have two groups. That's number one. Number two is that the two groups must be independent. They must not have anything in common at all. They must be what? They must be independent. Immediately you can establish this. Oh, that means that you can use.
Hello, sorry, please, I can't see your screen. Am I the only one that can't see his screen?
Yes, so you're the only one now.
To sample T test. Can you still see my screen, please? And you can hear me very
We can see your screen, but your network is breaking. We can't hear you well.
I can see your screen, but your voice is
We can't hear
skipping.
you.
It's really skipping.
Your voice is skipping, sir. We can't
We
hear you
cannot hear
well.
you clearly. I think the network from your end is very bad.
Hello, can you hear me?
No, we can't.
Yeah.
Yes, we can
Yes, we can hear you.
hear
We
you.
can hear you, but the
Yes, we
network
can
is
hear you,
sleeping.
sir.
Please, your screen is off again. I was seeing it just now, but it's off now.
Your screen is
The
not
screen
showing.
is showing, no. It's showing at my hand.
Can you hear me, please?
Yes, I
Yes,
can
sir.
hear you.
Yes, we can hear you, but your screen is not showing.
We can hear you, but can't see your screen.
Okay, just wait a minute. Can you see my screen now?
Yes.
Okay, let's continue. So for
Why
the
it off?
independent two sample t-test,
Okay. Okay.
number one, you must group, and the two groups. So it is typically applied when you have two separate groups. I've mentioned this, and you want to know whether their mean differs significantly. So in independent two sample t-test, the major thing that we are testing for here is the mean difference. Is there any difference in their mean? Is their mean statistically significant? So that is what we normally do in two sample t-test. Now, two sample independent t-test. Now, let's look at this. The group being compared must be independent of each other. This is very, very important. It is very, very important that the two groups must be what? Independent. This means that the individual in one group cannot be related to or peer with individual in another group. So that means that they don't have anything in common for the what? For the two groups. Now, what is the known hypothesis? How do we say our known hypothesis? Now, are equal. That is, there is no significant difference between the two groups. That means that, oh, if group one is equals to group two, that means that there is no difference between two of them. That means that the mean one is equals to the mean two. So that is what they mean by, oh, the mean of the two groups, the means of the two population are equal. That is, there is no significant difference between the two groups. Or you can write it mathematically like this: the H naught is the mu one is equals to mu two. So it's either you write it theoretically like this, or you write it mathematically like this. So this is how you write your known hypothesis. Now, let's check the alternative hypothesis. In writing out the alternative hypothesis, it will be what? The mean of the two populations are different. Remember that the non-hypothesis that we have here is saying what? The mean of the two population are equal. So this one is telling us that the mean of the two population are different. You can also put it that, oh, the mean of the two population are not equal any other way. So now, if you look at the mathematical part of it, you are going to see the mean one is not equals to mean two. For the two-tailed test, anytime you are having mean one is not equals to mean two, that means that you have what we call a two-tailed test. Now, if you look at this one, the alternative hypothesis, if this one is saying the mu one is greater than the mu2. Or you can also have mu1 is less than mu2. Anytime you are having one of these two alternatives, it means that we are having a one-tail test. Anytime you are having this greater than, or you are having something like less than, that means that you are having a one-tail test. But immediately you are having the mu1 is not equals to the mu2, that means that you are having a two-tail test. So let's proceed. Now, the test statistics for the independent two sample t-test, we have t to be equals to the x bar 1 minus the x bar 2, then minus mu1 minus mu2. So then we have the degree of freedom to be n1 plus n2 minus 2. Now, if you look at it, let me take them one after the other. If you look at it, the x bar 1 is the sample mean of the first group. The first group, the sample mean is x bar 1. The second group is the x bar 2. Then we have mu1 for the population mean of the first group, then mu2 for the population mean of the second group. Now let's look at this. If h naught is equals to mu1, if h naught is mu1 is equals to mu2. Now if I send mu2 inside, if mu2 cross this equation, equality sign, it will change to minus. So h naught, I'm going to have what? Mu1 minus mu2, which is equals to 0. If you come back here, please look here. If you come back here, mu1 minus mu2, we have here to be what? Mu1 minus mu2 is equals to 0. By the time I put that 0 here, this equation 7 will becomes equation 8. Look at this equation 8. We now left with what? X bar 1 minus x bar 2. Because mu1 minus mu2 from our non-hypothesis is equals to 0. By the time you put that 0 here, this equation 7 will reduce to equation 1, which is what? X bar 1 minus the what? Minus the x bar 2. Now, if you look at the denominator here, the denominator here is what we call the standard error. The standard error for this particular two sample independent t-test. Now, the first one that we are seeing here, the variance squared 1, that is the variance for the first for the first sample. Then the second one is what? The variance for the second group. The first group variance, the second group variance. Then the n1 is the sample size for the first group, while the n2 is the sample size for the second group. Any question before we move on, please?
Yes, sir. Please,
Yes,
I don't mind if you can come again, sir. It's not that clear, sir. It's not that clear, sir.
Okay.
So will you variance or standard deviation?
The square root of variance is standard deviation. So that is why there is square root here. So once you take the square root of variance, you have standard deviation. Let me take it again. Where should I take again, please?
From the formula, sir.
Yes,
Okay,
sir.
from the formula.
Excuse
Okay, thank you. So let's move our mind. Let me take it again from the formula. Now, the formula for two sample independent t-test is this equation 7 that you are seeing. This equation 7 that you are seeing is the formula for independent two sample t-test. The x bar 1 that you are seeing here is the mean of the group 1, the sample mean of the group 1. Then the x bar 2 that you are seeing here is the sample mean of the group of the what? Of the second group. Note that before you can use t-test, that means that you have small sample. So that means that we are the sample that we are considering for two sample independent t-test is a small sample. So the x bar 1 is the what? The mean, the sample mean for the first one. The x bar 2 is the sample mean for the second group. Then the mu1 is telling us the first population, and then the mu2 is telling us the what? The second population. Now we have this. Now we have this to be what? Mu1 minus mu2. Now let's come back to our non-hypothesis. If we check this non-hypothesis very well, we have mu1 is equals to mu2. Mu1 is equals to mu2. But I can rewrite this non-hypothesis again. Take mu2 inside. By the time this positive, we have positive mu2 here, cross this equation. Anytime positive cross equation, it will change to what? Minus. So that is why we have what? Mu1 minus mu2. Immediately mu2 leave this place like this, then we are left with what? With 0. So that means that mu1 minus mu2 is equals to 0. Do we understand this equation 7 before I move to equation 8? Please, I need response.
Yes, sir.
sir. No, sir.
Do we understand that equation 7?
No,
Yes,
sir.
sir.
The crossing
No,
of
yes, sir.
the
Is it
crossing
possible?
from the formula becoming
No, sir.
negative.
Excuse me, sir. Is it possible to miss equation 7 to go straight to equation 8 in exams? Or we have to state equation 7 before going to equation 8?
Okay. Thank you so much, ma. It is not necessary for us to state equation 7 before equation 8. We can use equation 8 in the exam straight. But the reason why I'm putting equation 7 there is that tomorrow you may come across any textbook, or you are working on this and you come across this equation 7, and you can be asking yourself, is this one being used for two sample independent t-tests? That is why I'm starting from that, and then I'm showing.
I've come across it. I've come across it somewhere and I didn't understand it. That was why I'm asking whether 8 equation 7 before equation 8. Now it is clear.
Okay.
And go to
Okay. Thank you, ma. Thank you, ma. So we must know this formula is very, very important. If you want to solve two sample independent t-tests, you must know this formula. It is very, very important. Now look at that equation 7. Then equation 7 can become equation 8, because by the time we have mu1 minus mu2 is equals to 0 already. Bring that 0 here. Once you put that 0 here, that means that everything here will become 0. Then we are left with what? X bar 1 minus X bar 2 minus 0. So when you subtract 0 from it, then we come back to equation 8, which is what? X bar 1 minus X bar 2. Now, the denominator that you are seeing here, if you recall from our confidence interval, I've shown this before under the confidence interval. When you have two sample or two population that they ask you to calculate their confidence interval, this standard error that you are seeing here is for unequal variance. It is for unequal variance that we call what? Heterogeneity of variance. I've made mention of that in confidence when we are calculating our confidence interval. You can revise that. Now, anytime you are having this, if the question asks you, assume heterogeneity of variance, that means they are talking about the unequal variance. So anytime you are working with unequal variance, you are going to divide it by your standard error by this. This is your standard error for unequal variance. But if the question does not state anything, by default, we normally use unequal variance. By default, we normally use unequal variance. So by the time you put this one, mu1 minus mu2 to be equals to 0, you are going to have equation 8. Okay, let's move.
Yes, sir.
Okay, now if you look at this second one, equation 9, it is, look at it, for equal variance or homogeneity of variance. Anytime you are hearing assume homogeneity of variance, assume homogeneity of variance, immediately you have that. That means that you are using equation 9. And then the only difference between equation 8 and equation 9 is the standard error. If you look at it, the denominator here is different from the denominator here. The denominator here is for unequal variance, while the denominator here is for equal variance. Now, the X bar 1 that you are still seeing here is still the sample mean of the first group. And then the X bar 2 that you are seeing here is the sample mean of the second group. By now, we should know how to calculate our mean. Our mean simply means summation fx over summation f for what? For grouped data. But if it is on grouped data, it means that you are going to sum all the observations that you have together, divided data, how to calculate your mean. So the mean X bar 1 that you are seeing here is the mean for the first group, while the mean of the X bar 2 that you are seeing here is the mean for the second group. Then we have the degree of freedom. It does not change. The N1 plus N2, that means that the sample of group 1 plus the sample of group 2 minus 2 will give you the degree of freedom for this. Now, the SP square that you are seeing here, we've talked about that under the confidence interval. The SP square that you are seeing here, it is what we call a pool variance. We call it a pool variance. Now, how do we get our SP square? Our SP square simply means what? The sample size for the group 1 minus 1 multiplied by the variance of the group 1, then plus the sample size for the group 2 minus 1 times the variance of the what? Of the group 2, then divided by n plus 1, the sample for the first group plus the sample for the second group minus 2, which is the same thing as your degree of freedom. If you look at this degree of freedom, is n1 plus n2 minus 2, and we're having it here. So anytime you are doing this, you are dividing this by n1 plus n2, you are dividing it by the degree of freedom. So by the time you do that, we are going to have what we call a pool variance. We're going to have what we call a pool variance. Now, bringing the pool variance inside this square root, then we have 1 divided by the observation for the first group plus 1 divided by the number of observation for the second group. So by the time you do justice to this, you are going to have the what? You are going to have the standard error for equal variance, which is homogeneity of variance. So by the time you use that to divide the denominator, you will have what we call the t-test statistic. You are going to have what we call the t-test statistic. So before we move to the question, let me have your question. So any questions so far, please? The floor is open. Please,
No, sir,
can you ask your question, please?
please, I have not really a question. Can you hear me?
I can hear you
Hello?
very well. Perfect. I can hear you.
Okay, sir. Okay, sir. Sir, please, why is there no key to identify the individual, what do you call, parameters so that we can easily recognize them?
The reason why I did not put individual parameter there is that we've written that in confidence interval. So, and as I'm saying it, I'm saying each of the parameters. So if you are looking at the slide, you can be listening to that my voice note too. That one we also define the parameter for you. We've defined the parameter before in our confidence interval. So, and I'm just thinking that to reduce the bulkiness of the slide. So let me just use Smart to explain since we have it already.
All right, no problem. Interval. Thank you, sir.
So any other question, please? All right.
Okay, sir.
Right.
I have a
Any other
question.
question?
I have a question.
I have a question.
Please go ahead.
I want to add that we always indicate that these unequal variance or heterogeneity of variance or homogeneity of variance in the question. We always indicate it.
Yes, they will tell you, oh, use equal variance, assume equal variance. But once they did not tell you, by default, we normally use unequal variance. If they did not specify, by default, we normally use unequal variance. So have I answered that question, please?
Yes,
please, I have a question.
Oh yeah, you two go ahead. Go ahead with your question, please.
For the degree of freedom
comma degree of freedom equals to n1 plus n2 minus 2. How are we going to calculate it? Because in the second one, the degree of freedom is what we divided everything by the degree of freedom somehow. Okay, no, we didn't divide though. Sorry, don't worry. Comma náà la padà ṣe. Don't worry. Thank you.
Okay, you've gotten it.
Okay, sir.
Okay. Any
I-
other question, please?
Yes, I have a question.
Go
This
ahead.
formula for t-test, where you have
Formula
sigma.
for
This formula that I'm looking at now, this formula for t-test.
okay.
So, yes. This denominator, the square root of sigma 1 squared plus another. That why we using sigma instead of sample variance.
I didn't get your question. Why are we using?
Why is this sigma instead of just x?
Why are
Hello,
we
sir.
using?
Why
Okay.
are
Are
we
we
using
using
sigma
variance,
instead of
population
s?
variance instead of sample
Why are we
variance?
Oh,
using
why are we using
population
sigma
variance
instead of
instead of
S?
samples variance?
Oh,
Yes.
good. Now, if you look at this, the first one that you are seeing here is the general formula. The sample that we are working with was drawn from a particular population. Population give birth to sample. Are we together now? So now, this one that you are seeing here is the general formula, whether it is sample or it is population. This one that you are seeing here is the general what? Is the general formula. Now, if you now look at the one for unequal variance, if you look at this, I'm trying to share my slide. If you look at this, can you see where I put S here? So I've narrowed this one
I
down.
can't see your screen, no.
Can you see my screen?
No, sir.
Sir,
Yes.
You cannot see my
I can see a screen.
his screen.
Okay. Now, this S that you are seeing here, it is the pool variance for sample. I've narrowed this one down. Are we together? So now in the question, if you are given, immediately you introduce this formula or this one, it means that the sample that you are using or the sample given is being drawn from a population, but the population variance is unknown. So you can further simplify this down by putting this one to be S. Once you put this one to be S, it will change to sample. But if you are writing this now and you further your calculation, then automatically you will calculate this for you to be using T. That means that your sample size is small and the population variance is unknown. That means that you cannot even get the population variance. So that means that you are going to migrate down to the sample variance. So this one that you are seeing here is the general formula. So now bringing it down to the form of sample. If it is unequal, that means that this one will just change to S. Remember from our point estimate, I listed it that the variance square, the sigma square is for the population, while the S square is for the sample. Am I clear with that, please? Am I clear with
Hello,
that?
sir. Hello.
Yes, ma.
Yes.
I can hear you,
Hello,
ma.
I
sir.
understand what you're saying.
Okay. In the exam, are we going to put this population variance or the sample variance in the equation?
Good. Now, in the exam, immediately you discover that you are asked to use homogeneity of variance, which is equal variance. Just you will put this equation here, this one that you are seeing, straight. Now, but if they ask you for unequal variance, immediately they ask you for unequal variance, immediately you introduce this or this. This is for just for the general. Then you can move down to the next line, and this guy here that you are seeing, the sigma square here, the sigma square here will just change to S square and S square. Did you get that, ma?
Okay, thank you.
Okay. The reason why I'm taking general to explain is that you can navigate from general. You can navigate from general. So you may be, it may not be even be 727. It may be journal that you are reading, that you just come across this formula. By the time there is what we call a funnel method. They will start from the origin, from the population, and they will narrow it down to where you need it. So that's why I'm using general to explain. So you still get your mark. Once you put this, then the next one, you know that it is sample, then you put your S. Any other question, please? Can we move on, please?
Yes, please.
Okay, thank you. So this particular question here
Sorry,
is
excuse me,
adapted
sir.
from, yes, ma.
Excuse me. Where we have the variance of sample 1 and variance of sample 2, can we use SD over root of
can we
1?
can we use SD?
Over
Yes,
root of 1 and SD2 over root of N2.
yes, you can use it because
And
by the time you take, yes, because by the time you take the square root of this variance, you will have standard deviation. So that it become SD for 1 divided by square root of N1 plus SD for 2 divided by square root of N2, because you've taken the square root of this. So once you take that square root, you change to variance. So it's allowed. It's allowed.
Thank you, sir.
Yes, ma'am. Okay. Let's look at our first question today. This question, we adapted it from 2020/2021 past question. So it's question 1 there. If I'm right, we've sent the question to the group. I think by now we should download the question and we should have it. In a study of factor associated with adverse effect of smoking on human reproduction, cardium level determination were made on placenta tissue of sample of 14 smoker mother and 18 non-smoker mother. The results were as follow. I'm going to show us the table, but let us look at the question that follows. State the known and alternative hypothesis for the study. Look at the mark. The mark is 4. Just for you to state the known and alternative hypothesis correctly, you have your what? You have your 4 marks. Now, the next one is, what statistical test will you suggest? And what is the degree of freedom, if any? That one is 3 marks. Now, look at the next one. State the assumption of the above named test. State the assumption of above named test. That is why I made mention the other time in our last class that the assumption is very, very important. You must know those assumptions. Now, look at the next one. Assume heterogeneity of variance. Look at this now. Assume heterogeneity of variance. That means that assume unequal variance. Compute the standard error for the difference in mean cardium level and evaluate your choice of statistical text. That is 7 marks. Now, number 5, conclude appropriately based on your results in what? In number 4, base your result in number 4 above. Int, its p-value is 0.02. Do we all get that question before we start solving it?
Yes, sir.
Yes, sir.
Okay, good. Let's move now. This is the table. If you look at this, we have smoker, we have non-smoker, and then we have smoker. The first one is 10, we have 8.4, we have 12.8, we have 25.0, up to the what? Sorry, this is supposed to be 18 for the non-smoker, then the smoker is 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Is it up to 18? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 12, 13, 14, 15, 16, 17,
It's
it remain 1. Supposed to be.
Yes, sir.
Please, can you check that question? Supposed to be 18. Then this one 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. One is mixing.
It's 18,
is it 18?
sir. 18.
Is it 18?
18. I've counted.
Please, can you confirm the question for me?
15 is the last on the smoker. Sorry, 15 is the last on the non-smoker.
It's 17.
And the smoker is 14. And that is 20.4. It's the last number.
The what, man?
For the non-smoker, 15
okay, from
is
the question, right?
15 is the last number there, sir. And it's 18. If you count, it starts from 10, 8.4, 12.8, 25.0, 11.8,
okay,
9.8, 12.5, 15.4.
11.8 is missing. 11.8 is missing.
11.8 is missing. After
yes,
which number?
11.8 is missing.
It's not missing what you sent, sir.
But we have 11.8 here.
No, in what you sent, it's not missing, sir. Maybe when you are capturing it, you missed it.
But okay, maybe when
after
After 25.0, after 25.0, you have 11.8.
Okay, after 25.0, we have 11.8 here, right?
Yes, then 9.8.
After 25.0, we have 11.8.
Yes, sir.
For the non-smoker, Abi?
Yes, sir. Then 9.8 instead of 8.8.
Do we all have that question?
I'm looking at the question right now, sir.
Okay, ma. Okay, ma. The first one is 10, followed by 8.4. I'm calling non-smoker now. The first one is 10, followed by 8.4, followed by 12.8.
Yes.
Then followed by 25.0.
25.0. Yes. 11.8.
Then followed by 8.8.
No, 11.8.
No.
Followed by 12.
Sir, please, followed by 11.8. After 25.0 is 11.8.
Which one is missing?
11.8 is missing.
11.8 is after what?
It's after
25.
Okay, it's missing for both, right? Both smoker and non-smoker. Is it missing for both?
11.8 appears 2 times on the non-smoker.
No, it appears 2 times there too.
Yes.
It appears 2 times.
Okay. Can you correct it and write the correct one down?
17 now, sir. We can work it with 17.
Because I've solved it inside my note here, and I've solved it. Okay. Because I've solved it inside my notes and I work with 18. Can you see it?
With 18. Okay, let's correct it.
Yes, it was when I was typing those data. So I'm going to correct that before I send the slide tomorrow. So please note that. Do we get that, please?
Yes.
Okay, let's move on. Now, the non-hypothesis that they asked you, which is 4 marks. So I took my time to really... who is this? Okay. So now, please look at this. The H naught is mu1 is equals to mu2. Then the alternative hypothesis is mu1 is not equals to mu2. If you express this like this, you are going to get your 4 good marks without stress. If you express it like this. But if you are the type that you love writing, you can take it like this. H naught is, there is no difference in cadmium level determination between smoking and non-smoking mother. There is no difference in cadmium level determination between smoking and non-smoking mother. If you are the type that you love writing, you can write it like this. Then the alternative hypothesis, please let's mute our mic. Alternative hypothesis is there is difference in cadmium level determination between smoking and non-smoking mother. So if you write it like this, you are going to have your 4 mark. If you write it mathematically like this, you are still going to have your 4 mark. Any question with the non-hypothesis before I proceed? Any question before I proceed?
No.
Can you still hear me?
You can proceed.
No question, sir.
You can proceed, sir.
Okay. Yes, sir. You can proceed.
You can see my screen?
Yes. Yes, sir.
Yes, sir.
Please, can you see my screen? Oh,
Yes.
okay, thank you. So, any of these hypotheses that we're having here, if you state it, you're still going to get your what? Your 4 good mark. Now, if you look at the next one, the next question here, the next question is, what statistical test will you suggest? Number one is you've discovered that the sample size is small. Now, the number two is you know that the population variance is not given. Then the number three is that we have 2 groups. So if they are asking you that, you should be able to supply them answer. Now, the test statistics that we're going to be using 2 sample independent t-test. 2 sample independent t-test. You can use 2 independent sample t-test. You can write it. Independent 2 sample t-test. You can write it. But if you write independent sample t-test, you will not get your mark. That 2 is very, very important. That 2 is telling us that we have 2 groups. So it is very, very important. Now, the other question that attached to it is the degree of freedom. Remember that the degree of freedom is what? We have the sample 1 plus the sample 2 minus 2. So by the time you add the sample 1, which is, we have what? We have 18 plus 14. So by the time you do that, we're going to have 32. 32 minus 2, we're going to have 30. So the degree of freedom for this particular question is 30. Now, for the assumption, please check the previous slide. No, okay. Now, for the assumption, because the number 3, they asked us for the assumption. We've stated the assumption for the t-test. Please check our previous slide. You will see the assumption for t-test. So I don't want to repeat that one again. Check the previous slide. Under the t, we stated the assumption for t-test. Now, let's move further. We have the standard error, but the question asks, assume equality of variance, which is heterogeneity of variance. If you look at this now that I'm calculating it now, can you see that it is S that I'm putting now? Now, so we have the S squared 1 over N1 plus the S squared 2 over N2. By now, we should know how to get our variance from the formula. So please, you will do that, do your variance, but when you do that, you are going to get 6.1986. That is for the first variance. 6.1986 square. So that you get something like this. Now, divided by this, by 18, then plus 6.814 square. Now, this 6 point that you are seeing here, if you look at this very well, this 6.198 that you are seeing here, if I did not square it, If I did not square it, it is your standard deviation. Because by the time this square will cancel the square root, I'm going to have 6.1986. So by the time I do this one square divided by 18, I'm going to have what we call what 2.1346. I'm going to have what 2.1346. By the time I square this divided by 14, I'm going to have 3.3166. Then adding them together, I'm going to have 5.4512. Taking the square root of this, I'm going to have 2.3348, which is the standard error for unequal variance. The standard error for unequal variance. Now, calculate the variance for the two groups using the variance formula. Okay, in our previous slide. So that's why I'm putting this statement. Please confirm by using the formula that we've written in our descriptive statistics on how to calculate variance. The essence of me doing this for you is that I want you to keep on practicing it, so you will know, oh, I have confidence that I know it now. Oh, maybe I'm trying to solve it, I didn't get it. You'll be able to ask questions. Oh, this is where you are making mistake, correct this. So that's why I'm putting all these things. I have them solved inside my notes, but I decided not to put it here so that you can cross-check and do it yourself. Now, if you use our formula, use the formula for mean. By the time you use the formula for mean, for the first one, you will just add everything that we are having here together, divided by the number of observations. You do the same thing for the second one, add everything that we're having here together, divided by the number of observations. By the time you do that, the x bar 1 is going to be 14.722. The x bar 1 is going to be 14.722. While the x bar 2 is going to be 20.4143 when you use those formula to confirm it. Now let's move on. So by the time we do that, look at this formula now. Then we have what? 14.722 minus this. So that means that the x bar 1 minus the x bar 2, then divided by this, which is the standard error that we've gotten from here. So now, by the time you do that, we're going to have, when you do the upper one, we're going to have negative, which is minus 5.6921 divided by 2.3348. By the time you divide this, we are going to have minus 2.4379. So,
what you are
any question on?
Sir, the screen is not
Any
showing you
question
what
on
you.
this?
Sir, the screen is
Is
not
not
showing
showing.
what you have just said.
It is showing, we can see it.
It
No,
is showing, please.
Not showing here.
Okay. Do you
when
mean this?
when it was substituting, it wasn't
Okay.
showing.
Look at the substitution. Can you see?
No,
Can you see the screen? Please
no.
check your internet.
Yes, we can see it.
Yes.
The screen is showing, because I'm also monitoring it with another phone. The screen is showing. Can
Yes,
we
I have a
proceed?
question, sir.
You have a question? Please go ahead.
Based on the first question they asked us, so how do to state the null and null hypothesis and the alternative hypothesis? Please, how do we know there is no difference in cadmium level determination, sir?
Okay. Now, anytime you are stating your non-hypothesis, always go with there is no difference, there is no association, there is no effect. So non-hypothesis always go with those words. We've mentioned that in our previous slide. So I think you are just joining us. So please, you can go through the other slide. But nonetheless, when you are calling out your non-hypothesis, always go with what? There is no difference. There is no significance. There is no association. There is no effect. Those are the words of non-hypothesis. Did you clear with that, sir?
Yeah, exactly, sir. Thank you.
Okay, good. Great. We can proceed. So please, I will ask for just 2 minutes. Let me put on the generator. My laptop light is going down. Just 2 minutes, please. Thank you.
I can't hear anything. Oh.
Excuse yourself.
You seem to be back.
I can't hear anything.
He said
He
he
too
went.
fast. He's
He
coming
is
now. He said he
coming.
went to want to game.
Chill.
You should calm down,
Relax.
Joe.
Are we writing the exam this night?
Okay, sorry, I'm back. Can you hear me now, please?
Yes.
Okay, thank you. So let's proceed, please. So when we do that, we're going to have this. Now, I think by now we know how to calculate our p-value using calculator. So we have a video on that, which we've sent to the group. So by the time you calculate your p-value here, if you put this value inside your calculator to get your p-value, you are going to have this, which is 0.00739. That's all you're going to have. But that is not your final p-value. The reason being that the test that we are doing is two-tailed test. Look at it. We've explained two-tailed the other time. Anytime you are having O, it is not equals to mu1, it is not equals to mu2. That is two-tailed test. Now, the p-value that we have here, you will multiply it by 2. Final, since we are working with two-tailed test, so we multiply it by what? By 2. So this one becomes 2 multiplied by 0.00739. So by the time you do that, we are going to have 0.01478. So we are going to have that. Now, I have a work for us in which you can just try it at your own convenient time. You will now assume equal variance, which is homogeneity. Assume equal variance, which is homogeneity. Compute the standard error. By the time you compute the standard error, compare it with the one we have here to check whether it will be the same. Assume homogeneity of variance. That will be our what? Our take home. Now let's continue. Now they ask us to, let's check the question. Let's check the question. Like, oh, okay, after this one, we've stated this, we've calculated it. Now, conclude appropriately based on your result in this. The p-value, okay, the int, its p-value is equals to 0.2. You may ask me, oh, why are we not getting 0.02 here? We have a lot of reason behind this. Assuming this our last value here is 5. By the time we approximate it, it's going to be 0.02, which is placed by system. And you know, when we were trying to use our calculator to do it, we'll have approximate some values, which the system will just compute straight without the approximation. Now, if you look at this now, we have been given the p-value to be equals to what? To be equals to 0.02. 0.02. So it is now this p-value that we're going to use to make our decision. Now look at the decision rule. The decision rule, reject H naught. Please, if you are rejecting, you must state what you are rejecting. Someone sent me a work. He wrote reject. If this, what are you rejecting? You must put it. I've corrected that for that person. Reject H naught or reject non-hypothesis if the p-value is less than the significance level, which is alpha, the level of significance, which is alpha. Alpha is the level of significance. Otherwise, do not reject. Now, after you've stated your decision rule, the next thing is to make decision. Now, look at the decision. Since the p-value given, you are not the one that computed it. They gave you this p-value. Please, it is very, very important. You were given this p-value. You are not the one that computed it. Since the p-value given is
0.02.
Hello, I can't hear anything. Oh.
You're not the only one, ma. I can't hear anything as well.
Thank you.
Sorry, can you hear me?
Yes, sir.
You can hear,
Welcome.
we can hear
Sorry,
you.
Yes, sir.
I'm sorry. Okay, let's look at it now. The decision now, since the p-value given 0.02 is less than the level of significant alpha, we reject the null hypothesis. Please and please, you have to state all these things one by one. You see the way I stated it here. You have to state it one by one so that you will not miss any mark. If this decision rule, let's look at it. Let's look at it. I think they put mark there. If you check it, I think is it 2 marks or 3 marks. So to get your 3 marks correctly, you have to state it like this. You state the decision rule, you state the decision, then conclusion. Anytime you are, now that we are rejecting the non-hypothesis, there is sufficient evidence. I have to put there here. There is sufficient evidence from the data that cadmium level determination made on placenta tissue of smoking mother and non-smoking mother were statistically significant difference. You know, in our non-hypothesis, if it is non-hypothesis I'm stating with this word statistically significant, it's going to be not statistically significant. And then the alternative hypothesis will be it is what statistically significant. Now that I'm rejecting the one that is saying not statistically significant, that means that we are left with the one with what statistically significant. So we're statistically significant difference. Hence, there is effect of smoking on human reproduction. Can you see it, please?
Yes, sir.
Why everybody just cold tonight? What is
Yes,
going on?
yes, sir. But I have a
Okay,
question.
please go ahead, ma. Please go ahead with your question.
Sir. Please, sir, we have calculated the p-value to be 0.01478. When are we using that value to compute to decide?
Okay, if you are not given the p-value.
Excuse me, sir,
if you are not
because
given,
I have not finished,
okay,
sir.
go ahead.
To be
Okay.
given the p-value given to be 0.0 to know that we are taking the p-value on our own to be 0.05. The p-value that we got in now is 0.01478. When are we using that one to interpret or to conclude our decision? Or to
Okay,
conclude
ma.
our
Okay, let me quickly react to that. Immediately you are given the p-value from the question. Just it is that p-value you are going to use. The essence of we computing our own p-value is that, oh, let us cross-check whether we are going to have the same p-value as their own. And the subsequent question that we have been solving, we are having it. But if you check, if we can continue with, all the number that the calculator is giving us, it is what we are using. At the end of the day, we are going to arrive at the same thing, which is 0.02. Because by the time we input all the number given from the calculator, the 4 that you are seeing here will have increased to like 5 or 6. And then we are considering 2 decimal place. Then the 4 or 5 here that will have getting to 5. If you approximate it, we are still going to have 0.02. So the essence of we computing this is that, I want to use this to confirm whether what I'm doing is right or wrong. But for this p-value that we computed, there's no mark for it actually, because we have been given the p-value from the question. They are just expecting us to stop at this test statistics value that we have. But just for us to confirm, is it what I'm doing? Is it right or wrong?
Thank you,
What
sir.
I'm doing correctly, is it right or wrong. That's why we furthermore to us to compute our p-value. But on the p-value, you will use that one to make conclusion. But if you are not given the p-value, then you will compute the p-value yourself and use it to make conclusion. Any other question, please?
Yes, sir, I have a question. Other questions we have been past questions. Past questions we've been solving. When you advised us that when we calculate our statistics, test of statistics, our p-value, and then is given again as another part of the question, that we should quickly check our own if there is a mistake and correct it. So here now, why are we not correcting this one? We are just leaving it like that. Or should we just leave it like this?
Okay. Let me quickly react to that. I may mention something that if you can keep all the value given from the calculator, you know, when you use system to run it, system will just compute the whole value for you. Now, if you can bring out all the value, maybe it is 10 digits that follow points from the calculator. By the time you do that, you can practice that. By the time you do that, this 4 that you are seeing here will have gotten to like 5 or 6, in which you can approximate to make this one to be 0.02. That's what I'm saying.
Even sorry,
So
sir.
for
Even
this one,
sorry. Even the answer we got, the 0.0145. That
So
seven
in
at the
short,
back.
sir,
When you
so sir,
set
in
it
short,
to
sir, they've already
0.5,
calculated.
it's still the same thing.
That's why they gave us the 0.0. Sir, it
yes,
then
I'm
means
with you.
they calculated it and found it to be 0.02. That's why they put it there, Abby.
Okay. Yes.
So we just have to compute with, we just have to decide with the normal level of signal that normally take as 0.05. So I don't think we really need to work all these things dealing with it in the exam, sir.
Okay, but before you can make decision, you need something to compare with something. You need p-value to compare with the level of significance. So the hint given there is that as you are doing it, your p-value will be around that range. Are we together now?
Yes, sir.
So if you are making your decision, you make decision based on that p-value given.
P-value given. Okay, thank you, sir.
Do we get that? All right.
Sir, I got it, sir.
All right. Let's move. All right. Thank you, sir. Thank you, ma. Let's move on, please. So at this point, we've come to the end of t-test. We've talked about one sample t-test. We've talked about dependent or peer t-test. And we've talked about independent two sample t-test. So by now, anytime you are seeing a question, you should be able to know the type of test that you are going to apply, whether it is t-test or z-test. Or whether when it is t-test, what type of t-test. By now, you should also know the type of t-test that you are going to apply. Okay, let's move to the next test, which is called the f-test.
Excuse me, sir.
Before that, please and please.
Practical.
Okay, man.
Excuse me, assuming we are the one running our own research questions. I mean, you are our own research work, and this thing is more than, like, our population is about, or our sample size about 435 or 650. Which type of test are we going to use for those? Because here we are saying if it's set test, set score, set test, t-test. It means if our sample is smaller than 30, you use t-test. If it's larger than 30, it doesn't mean that if you have something that you have to compare, or you have independent samples. For example, somebody working on mothers, mothers and fathers. When there are two independent people, and there is heterogeneity of the information to be given. Are you going to use t-test for those ones, or will you use Z-score for the two samples given. And we are comparing their
Okay.
attitude, mothers to immunization, attitude of fathers to immunization.
Now, mommy, what you just play out now is that our one of the group we have is either it is man or woman, right?
Yes,
Which
sir.
is two groups.
Yes, sir.
Now, if you consider your sample to be large, immediately you have the large sample, you can no longer use T. T has to satisfy the two criteria: less than 30 small sample size and the population variance unknown. T must satisfy the two before you can use T. And since you are working with two groups, that means that you are still going to go back to your Z. But assuming that you are working with three groups now, that means you can't use Z, you can't use T.
Over.
Do we get that, please, ma?
Yes, sir. We use F-test.
Okay. All
Thank
right.
you.
Thank you. Thank you. Yes, ma. So lastly, before we move to F-test, if you recall, under our descriptive statistics, we solve a particular question that is relating to what's it called? Is it smoking? Okay, the smoking, then the age status, and the likes. Under our descriptive statistics, we started a question under that, the past question of 2022-2023. Now we want to answer the 2C part of it, the 2C Roman figure 1 and Roman figure 3. Because the last time when we were treating it, I mentioned that when we get to testing of hypothesis, we are going to solve it. Please, and for those people that sent me a message that we did not complete their part of that question, this is the what? This is the remaining one. Okay, let's move down. We've treated A and B in our descriptive statistics lecture. Now the C part, with reason. State the appropriate statistical method you will use for the following. Test the effect of cigarette smoking on phenasticin metabolism. Now, if you check the phenasticin metabolism level and then the effect of smoking, the smoking effect and the phenasticin metabolism, there are two groups: the smoker group, the non-smoker group. Let's put them as smoking. Okay, the smoking group, then we have the phenasticin level. Smoking group is one group. Now we have the phenasticin level, another group. So we have two groups. Now, in that case, we use what we call two sample independent t-test. If you check our sample that we have for the non-smoker and the smoker, none of them is greater than 30. If you go and cross-check it, under our descriptive statistics, the first question that we treated, none of them is greater than 30. So you cannot use the Z test. Number one, we have the small sample size. And then number two, they did not mention that we have a population variance. In that our descriptive statistics question, that number two of 2022-2023 past question. So we cannot use Z test, but the test that we are using there is two sample independent t-test. What is the reason? The reason is because we are checking the effect of cigarette smoking on phenasticin metabolism on two different groups. We have two groups. We have the smoking and the non-smoking. The smoker and the non-smoker. Do we get that one, please?
Yes, sir.
Okay. Now, the next question there is examine the relationship between the age and phenasticin metabolism. Now, if you look at the age from that question, the age is given as a continuous. What did I mean by a continuous? It's a numeric. The age, they gave us the number, not group. They did not group the age that, oh, from 0 to 30, from 31 to 60. They did not group the age. The age given to us is numeric. So now we have the numeric age, and then the phenasticin metabolism given from that question too is also a numeric value. So we have the numeric value correlation. We use what we call what? a Pearson correlation. By the time we get to correlation and regression, I'm still going to explain more about the Pearson correlation. We are trying to check the strength between the age and the phenacetin metabolism. Now, assuming that the age is being grouped, let's say I have the group age from 0 to 10, from 11 to 20, from 21 to let's say 29. The age has been grouped. Then we will use what we call Spearman rank correlation. We use what we call Spearman rank correlation. Immediately the age is grouped. But since the age is continue, we use what we call a Pearson correlation. And a Pearson correlation, I don't know, maybe you've caught across that in statistics, that you have a parametric test or non-parametric test. So parametric test simply means that those people that follow assumption, those that follow assumption, any test that follow assumption is a parametric test. Please take note of that. Tomorrow you will start your research. They may ask you, which test are you using? I'm using a non-parametric test. Why? Because it does not follow assumption. Maybe your data don't follow assumption. It's not every data that will follow the assumption of normal distribution, and it's not every data that will follow a parametric assumption. That's why we have non-parametrics. So it's either you have a parametrics or non-parametrics. So any test that follow assumption is called a parametric test, and any test that does not follow assumption, it is called a non-parametric test. So Pearson correlation is a what? Is a parametric test. But when you are talking about the Spearman rank correlation follow a what? A non-parametric test. Now, Pearson correlation coefficient, because it follow a parametric assumption, which we have stated for the t-test. So the assumption that we've stated for the t-test is what? A parametrics. Because if you are considering that value, look at it. If you are considering the smoking and non-smoker against the phenacetin level, we've talked about that. It is two sample independent t-tests. And before you can use two sample independent t-tests, there are assumptions that we have for the t-test. So now, since it has satisfied those assumptions, automatically, if you are using Pearson correlation, it means that it's also what? Because a Pearson correlation is a parametric test. Any question on that? Are we still together?
Yes, so
Does
Sir,
it
it's
mean,
not clear,
excuse me,
sir. He's a bit
does it
confused,
mean
sir.
that the assumption of parametric test, that parametric test is the same thing as that of independent t-test?
Can you still hear me, please?
Yes, sir. Please, I have a
We can hear you.
clarification, sir. I need a clarification, sir. You said when we are talking of parametric assumption, when we have assumption, parametric assumption, we use Pearson's test. And that one is that if we are using Pearson's parametric assumption, if the sample size is less than 30, I'm not asking, does it mean that the assumption of independent t-test work for Pearson's parametric assumption?
Okay, let me quickly react to that. Please note that in statistics, is that you have parametric test or non-parametric test. A parametric test are tests that follow assumptions. And while a non-parametric test, they are tests that they did not care about the assumption. They will work. Now, the question given to us, that number 2 question, if you look at it very well, we've tested some assumption on it before we can say that, we are using 2 sample independent t-test. That means that it has satisfied the assumption of t-test before we can say we are using it. So automatically, that particular question, any test that you are performing on it is a parametric test. And then t-test is a parametric test because it takes assumption. Now, if you now want to find the strength or the relationship between that 2 groups, that they are continuous, if you check it very well, if you check that 2 groups that are continuous very well, we have what? We have the age and the phenacetin metabolism. Now, if you want to check the strength, we have two types. We have the one for non-parametrics, and then we have the one for parametrics. Now, since we've confirmed that this particular question that we are treating is a parametrics because we've used T in two sample independent T test on it, so automatically it follow a parametrics method. Now, let us now come back to the testing of the strength or the association or the relationship. Now, we have the parametric method that we normally use, and then we have non-parametrics method that we normally use. Now, if you now check the parametrics method that we normally use is what we call a Pearson correlation. The parametric test that we normally use is what we call a Pearson correlation. Since we've confirmed from the t-test, before we can use t-test, that means that it satisfies the parametrics. So automatically getting the strength now, we go for the one with parametrics. But assuming I
see your slide. I don't know, maybe it's from my hand alone.
Can you see my slide?
Hello, can let's
Yes.
no sir, no sir.
Okay.
No sir.
Yes, sir.
Yeah.
Yes, sir. I can
Yes,
see your
we can
slide.
see it.
Please check your network. Please check your network, or you exit and then you come in again. So please check. Now, so as I was saying, we have the Pearson correlation to check for the strength, because that particular data or that question that we are treating has satisfied a parametrics test, or sorry, it has satisfied a parametrics assumption. So that is why we are using Pearson. Any question?
Excuse me, sir.
I'm with you.
Excuse me, sir.
I'm with you.
You were saying something about the Pearson correlation coefficient, but I thought the man said, like the man who taught us this particular lecture, like when we got to that ANOVA part, actually. So I think he said, if we don't want to use this Pearson correlation, he said we can use this Spearman. Is it like, are you trying to say that these two, this thing are like, I know they are different, but is there a way that, like, I don't know how to put it. Is there a way that, let's maybe there is a place we are going to use Pearson correlation, and we are going to use Spearman rank correlation? Like, is it two different things, or they can still use to be solved for the same thing?
Okay, let me quickly react to that. Look at that statement, is Spearman rank. If you recall, when we started the non-hypothesis, I made mention that it's either you have a categorical data, or you have a continuous data. And then under the categorical data, we have nominal and ordinal. Ordinal is being ranked. Are we together now? And then ordinal and nominal, please mute your mic. Ordinal and nominal, they are under categorical. So ordinal and nominal, they are what? Under categorical, which is qualitative. So anytime you are having that categorical, we use Spearman rank, because we are dealing with ranking. So when we get to Spearman rank, I'm going to show us maybe one or two examples how to use Spearman rank. You will see that it's just ranking. So Spearman rank is under non-parametric. Spearman rank is under non-parametrics. Then Pearson correlation is under parametrics. And then any data or any question that does not satisfy a parametric text, we normally use what we call a non-parametrics. So please, Spearman rank is in category of non-parametrics, because we normally use to rank. And then when we are dealing with ranking belongs to the category of what? Of nominal and ordinal, which is under what? Qualitative. And then the other part, which is what? Which is scale, and which is ratio and interval, is under quantitative, which is continuous. So please don't mingle them together. That is why you have to separate your variable. Immediately you have your variable, you separate them. Oh, you belong to here, you belong to categorical, or you belong to continuous. So by the time you do that, you will know those that satisfy the assumption. You will know those that is not satisfied the assumption. You will know those that you will use non-parametrics for. You will know those that you will use parametrics for. So it is very, very important. Am I clear, please?
Yes, sir. Thank you.
Okay. Thank you. Any other question? Can we move on? We still have a long way to go tonight.
Yes.
Okay, let's move. Let's move. Now, if you look at the last one, investigate the joint influence of cigarette smoking and age. If you look at this, we are now considering two now: the cigarette smoking and age on phenacetin metabolism. Now, on phenacetin metabolism. So that means that the phenacetin metabolism is depending now age and smoking now. Oh, the age and the level of smoking will determine your phenacetin metabolism. So in that case, by the time we get to regression, I'm going to explain more. It's because people have been asking me, you did not finish that your first question that you solved. That's why I have to just bring in it now. So I'm planning of bringing all this one under correlation and regression before, but let me quickly explain this. Now, anytime you are finding a joint influence, immediately you discover that all the variables that we have there is more than two. Sorry, it's more than one. We are now having two. Pearson correlation or the Spearman rank, they can only handle two variables. That's why we're having two here. So immediately your variable is more than two. Immediately your variable is more than two, we move to what we call the regression. And then under the regression, we have the linear regression, simple linear regression, and then we have multiple linear. To do more on that when we get to that particular one. So now, anytime you have your simple linear regression, it means you have one dependent variable and one independent variable for simple linear regression. But anytime you have one dependent variable and more than one independent variable, that is, you have one dependent variable, you now have two independent variable or two or more independent variable. That means that we normally use what we call multiple linear regression. Multiple linear regression. So now we have two independent variables, the cigarette smoking and the age. Now we now have dependent variable. The dependent variable is the what? Is the phenacetin metabolism. So that means that the age and the smoking status or the cigarette smoking is now what it's going to give us the result for what? For phenacetin metabolism. So in that case, we use what we call multiple linear regression because we have more than one variable that are depending on phenacetin metabolism. So any question before we move to the next one?
Hello, sir. So for the question that you just they investigate the joint influence of cigarette smoking and age. Is it going to be just to mention
Yes,
that
ma'am.
it's multiple linear regression or there is a calculation for it? There should be a test statistic and then the formula for it and all those ones. Or is it just to mention what we're going to use for it?
Now the question just asks us to mention it. So there
So
is rigorous statistics.
investigate the joint.
That's what they ask. If you read the
Oh,
C question with reason, state appropriate statistical method you will use for this following. They just want you to state it that you will use. Can you see the question, ma? Hello, are we still together?
we're together, sir.
Yes, sir.
Okay, can
We
we
are
move on?
together, sir.
Sorry.
Yes, sir.
Sorry. Before.
Okay, let's move to
That anyway.
the F test. So we are moving to
Sir, please before
the
the
F
F
test. Please
test.
mute your mic, please.
Sorry, sir. I said sorry before the F test. That place they say investigate the joint. That's what I'm asking. Is it just to mention that it's multiple linear regression and then mention why? State the reason why we are using it. Because investigating, I was thinking maybe there would be formula or something, or there's no need. I just want to get this.
There is no formula here. With reason. Look at the question,
Oh,
ma. With reason. State an appropriate statistical method you will what? You will use for the following. They just want you to state it. They didn't ask you to calculate
yes,
it.
sir.
Just state it.
Okay.
Yes, ma'am.
Hello.
Thank you.
I'm
Hello,
with you,
sir.
ma.
Okay. In this question, is the phenacetin metabolism the dependent variable or
Because from the reason you gave, you said because we have more than one variable that are depending on phenetic metabolism. I think the cigarette and the smoking, the cigarette smoking and age is are the predictors. Do you get what I'm trying to say?
Yes, you are right, ma. The cigarette and age are the predictor. Why the phenacetin level is the what? Is the response. So the phenacetin level is the Y. And the Y is called dependent variable. Another name for Y, which is dependent variable, is what we call what? The outcome variable. Another name for Y is what we call the effect variable. So if anybody is taking cigarette with his age, the effect that people will see outside is what? Is the phenacetin metabolism. So the phenacetin metabolism result depend on the cigarette smoking and the age. So the age and the what and the smoking and the cigarette smoking, they are what? They are independent variable. Another name for independent variable is called the explanatory variable. Another name for explanatory variable is what we call what? The treatment. Oh, we are giving me, I'm taking in a drug now. Oh, maybe I'm having a headache, I took in a drug. The drug that I'm taking is what is the treatment. Now the response, oh, after 1 hour, the headache is vanished. So that is the response. That is what? That is the dependent variable. So that headache depend on the what? On that drug. So here now the phenacetin level is what? Is depending on what? On the age and the cigarette smoking. Is that one clear, please?
Yes, thank you.
Yeah, but the statement you made here, where you said because we have more than one variable
Yes,
that
sir.
are depending on phenacetin metabolism, is contradicting what you just said.
So that's the part that is not clear, sir.
Immediately you have one dependent variable and one independent variable. It is called simple linear regression. Assuming that we are taking just only age. Are we together now? Where they are now asking what is the influence of age on metabolism level, not relationship this time around. The influence of age on metabolism on the phenacetin level. Now that one is no longer multiple, is simple linear regression because we are considering just one independent variable, which is age. But now we have more than one independent variable. Anytime you have more than one independent variable on one dependent variable, we normally use what we call multiple linear regression. Multiple linear regression. The two independent variables that we're having here is the age and the cigarette smoking. Am I clear with that, please?
Yes, sir.
Okay. Any other question before we move to F test?
Yes, sir.
Okay.
Yes, sir. The statement you wrote are because we have more than one variable that are depending on phenacetin metabolism.
Okay.
The phenacetin metabolism, the phenacetin metabolism is dependent variable that is depending on the age.
Oh, thank you. I can see. I can see that.
That's what
Sorry.
I'm saying.
I can see
That's
that.
what I'm saying.
Oh, sorry. I can see that now. I can see that now. Because we have more than one.
That means we have more than two independent variables.
Yes.
We have more than one variable. That will be the multiple.
Okay.
We have more than one variable. Whether it is dependent or independent, we have more than one variable.
Okay. Now, the correct one that we're supposed to have here should be independent. We have more than one independent variable.
Yes.
Thank you. Thank you, ma. Thank you, ma. We have more than one independent variable. Please help me to note that so that I can let me notice down so that I can correct that before I send the slides tomorrow, because we have more than one independent variable. Thank you, ma. Thank you, ma. I appreciate this. Thank you so much. Any other question? Can we move on?
Sir.
Yes, we can move on.
Okay. Now we move to another test called the F test. And this time around, please and please, I just want us to calm and listen so that we can get it. And the what's it called? The question on F test should be one of the questions you should be able to solve in the exam. And apart from exam, the major tests that were carried out in, let's say, public health or in medicine or pharmacy is based on you being analyzed. They normally use analysis of variance very well because they analyze the drug, they analyze vaccine, they do all sort of things with what, with the analysis of variance. So please and please, the analysis of variance that you want to learn here tonight is even beyond 727. You will use this in 727 and pass, but it's beyond what, 727. So let's start. Oftentimes, the mean of more than two independent sample needs to be compared. Oh, I have more than two independent group. Let me put it like that. Definitely, one could perform multiple t-tests. Let's say, for instance, remember that the criteria for using F test is that your group must be more than two. Immediately your group is more than two, you cannot use t-test again, but F test. It's not that you cannot use t-test. There is what we call a comparison test. This particular question came out in your test that they have three groups. That what is the error that is likely to occur when they are using two sample independent t-test. When you are doing the comparison, that is, I have three groups. Let's say I have group 1, group 2, group 3. If I want to use t-test, I will first of all compare group. I'm going to take group 1 and group 2 together. I will do the analysis. I will take group 1 and group 3 together. I will do the analysis. I will take group 2 and group 3 together, and I will also do the analysis. And it's prompt to type 1 error. It is very easy to commit a type 1 error by doing comparison analysis. But there is another way around, which is called the F test, that can handle the all three at once, which will limit or will reduce our chances of committing a type 1 error. So that is why they are using the F test. Oh, immediately you discover that you have more than two groups, you can no longer use Z, neither you can use T, but you will use F. And note this, analysis of variance is not a test. Analysis of variance is not a test. Don't be saying that, oh, I'm performing the test of analysis of variance. If I'm in that seminar and you say something like that, I'm going to call you back that, oh, Mr. Man or Madam, I don't think you really understand the concept of analysis of variance, because analysis of variance is not a test. Analysis of variance is just an experiment that we perform to get the F test. Analysis of variance is just the experiment that we perform to get the F test. Now let me quickly run through what I have here. Definitely one could perform multiple t-tests. That's what I said the other time, but many require a great amount of work and
Please, can
increase
you
the
come
probability
again?
of type 1 error. On where, ma?
Like
Where?
when you
Please
were trying
answer, please.
to differentiate between F test and T test, that place was a little confusing.
Okay. Now, if you are using F test, the criteria for selecting F test is that your group must be more than two. So once your group is more than two, you cannot use Z test, you cannot use T test, but the F test. Is that one clear? Is that one clear,
Yes,
please?
it is.
Okay, thank you.
Yes,
So
that's
let's
clear.
proceed. Okay, now overcoming this challenge, like the challenge of doing comparison tests with T, F test is designed to simultaneously comparing this mean in one step through the analysis of variance approach. Now, assumption of F test in analysis of variance. What are the tendency? Observation in each group must be independent of each other before you can use before you can use test. which you want to use the experiment of analysis of variance, your what? Your observation in each group must be independent. Number two assumption is normality assumption. That is, the data within each group should be approximately normally distributed. So analysis of variance experiments follow a normality assumption. Now, number three that you have to also consider as part of the assumption of F-test when you are using analysis of variance experiment is what we call homogeneity of variance. Homogeneity of variance. That is the language that common. Oh, is equal variance. Homogeneity of variance is equal variance. Now, but in analysis of variance, there is what we call homoscedasticity. Homoscedasticity simply means that the variance within the group should be roughly equal. By the time the variance within each group is equal, it is called what? Homoscedasticity. Homoscedasticity is the assumption that is very, very important when you are considering what? Analysis of variance experiments. If you are using analysis of variance experiments in your project and you did not state homoscedasticity there, if a statistician is there when you are presenting, you may have a little challenges, because it's going to ask you, why are you not putting homoscedasticity of variance? Because we should assume that within each group there should be a what? Equal variance. And then lastly, about the assumption for using F-test, the sample size may or may not be equal. It's part of the test that they brought, that which of the following is not assumption of, I think, F-test, that the sample must be equal. No, the sample can be equal. You may have equal sample and you may have unequal sample. The reason why we have unequal sample, for instance, is that, oh, maybe you've recruited some people to different groups. Let's say you are doing a clinical trial. You've recruited them. We have group 1, group 2, group 3. And all of a sudden, one of them just decide, oh, I'm no longer interested in this research again. Oh, I'm no longer interested in this experiment again. I'm opting out. So immediately that one opted out like that, that means that you are going to stop the experiment? No, we're still going to continue with the number of people that is remaining in that experiment. That is why the sample size may equal and may not be equal. Any question or clarification on the assumption? The floor is open. Or we should move on.
Question, sir.
Okay, go ahead, please. Go ahead, please.
Question. Please, could you please throw more light on the homoscedasticity?
Okay. Thank you. Now, as we are moving further, you will be seeing some language that you'll be seeing something like, oh, sum of square between, sum of square within. You've heard about that when they are treating the analysis of variance. Now, within the group, there must be a equal variance, because in analysis of variance in F-test, we just analyze variance. That's why they are calling it analysis of variance. So now, anytime we assume that within that group that we are working with, within group 1 to group 2 to group 3 that we are working in, there should be an equal variance. So immediately we assume that, oh, the assumption is that within each group, within the group, there is what? Equal variance. So immediately you make that assumption, that means that we have what we call homoscedasticity. Homoscedasticity means that there is equal variance within the group. That's just the simple language of homoscedasticity. Do we get that, please?
It's okay, sir.
You did not get that, because that is okay. Does not sound that you understand it.
Okay, sir.
Let me take it again.
Before you take it again.
Okay.
In writing it in our exam, do we need to put that homoscedasticity, or can we just say the variance within the group should
you can
be...
just put homogeneity. The essence of me saying homoscedasticity is that majorly is for those people in pharmacy, because they normally use this number very well, and those people in nursing, At least last week now, someone brought a thesis, a PhD thesis for Dr. Folabi to review, and then we check it, and majorly it is analysis of variance that they are using, and the homoscedasticity of variance is very, very important when you are doing your experiment. It's very, very important. So that is why I'm still amani homoscedasticity. Majorly, it may not be useful for you in 727. You just state, independency, normality, then homogeneity of variance. But if you are doing experiments, or you are writing your project, or you are writing your dissertation or thesis, and you are using analysis of variance experiments, homoscedasticity is very, very important. Can we move on? Can we move on, please?
Sir, please, I want to ask, that homogeneity and homoscedasticity, are they not the same thing, since they are both like meaning equal variance?
Ma, can we move on?
Did you hear my question, sir?
I did not hear your question, ma.
Okay, I was
Can
asking
you
that
ask again?
since, like, yes, you said homoscedasticity is equal variance. Homogeneity too is equal variance. So, like, what's
Within the
the
group,
difference?
within the group. Homoscedasticity is within the group. Homoscedasticity is within the group. The homogeneity is like you are assuming that all the observations, they have equal variance. Homogeneity is, assume that equal variance in the observation. But homoscedasticity is, we assume equal variance within the group. Did you get the difference between the two now?
Okay, sir, yes, I understand now. Thank
Oh,
you, sir.
okay.
No, sir, I didn't get that, sir.
Okay. Homogeneity is, we assume equal variance in the data set that we have. But homoscedasticity is, we assume equal variance within the group. The group 1, group 2, group 3, group 4, group 5. Irrespective, since your group is more than 2, we in that group, which is what equal variance within that group. Do you get that?
Yes, sir.
Okay, let's move on. So now, in analysis of variance, we have 2 types, even more than 2 types, but I just want to narrow it down to 2 types. We have one-way analysis of variance, we have 2-way analysis of variance, we have 3-way analysis of variance called Latin square, we have 4-way analysis of variance called Greco-Latin square, we have 5-way analysis of variance called Hyper-Greco-Latin square. And that one, I think that one is beyond this level, but if you are doing your PhD and you are working with this, you will understand better. But as far as 727 is concerned, we're going to talk about 2, but out of that 2, it is even only 1 that they taught in class. And check the past question over the year, is 1 that they normally set question on, and which is what? One-way analysis of variance. One-way analysis of variance. Then what is one-way analysis of variance? Compare the mean of more than 2 groups based on a single factor. Based on a what? A single factor. Let me use simple scenario that you will easily understand. Let's say I have a group of those that have diabetes. Those people that they've been diagnosed that, they have diabetes. Now, I have some people from the north. Let me call them N. They are from the north. Then I took another sample from the east. Let me call it E. From the east, those people that have diabetes. And I have another sample from the west. So now I have 3 groups: the group of the north, the group of the east, and the group of the west. They have diabetes. Let's say, for instance, there is this pharmaceutical company that they normally produce drug. They've produced a particular drug that can what? That can cater for diabetes. Okay, we have the drug now. So we have first group, which is north, the northern people. We have another group, which is what? The eastern people. And then we have another group, which is western people. Now, giving them that drug alone, I've administered the drugs to them. Now, if you are giving them, it is only that drug that you are giving them. So that is the only single factor that we are measuring. We are measuring whether that drug work effectively, or whether the potency of that drug work. whether the potency of that drug still function, whether that drug has not lost its potency. So it's just a single factor, which is that drug. So in that way, if we want to do the analysis, we normally use what we call one-way analysis of variance. One-way analysis of variance, because it is the only treatment that we are giving them. It is the treatment factor that we are consider. We don't consider other factor. That is what one-way analysis of variance. We are giving them only drug. Now, let us now say another researcher now came up that, oh, the reason why this drug is working, maybe it's because of the climate change. Maybe it's because in the northern area there is hot, there is high temperature in northern area. That is why that drug is not working very well. Or maybe it's because in the southern parts of Nigeria that we have, oh, maybe it's because the weather there is moderate. That is why the drug is working effectively. So immediately you now consider another factor called climate change. In the same set of people, now we are now considering two things. We are considering the factor of drug, and then we are considering the factor of climate. Now, if you are now considering that two things on this single the people from the north, the people from the east, and the people from the west, then we now have two factors called two-way analysis of variance. But if it is just only one factor, which is treatment that you are considering, it is called one-way analysis of variance. But bringing another factor in, it is called two-way analysis of variance. Now, let me now add another thing to it to make it three-way. Let's say, for instance, and I consider the diet that these people are taking. Now, we now have the drug that they are taking. We've considered the climate. Then now we are now considering the diet. Oh, is it the food that they are taking that is contributing to their low in diabetes? Now, we now have three factor. Immediately we have that three factor. It is what we call three-way analysis of variance, or we call it a Latin square method. So that one is beyond the class. So if you are still taking another factor, immediately you are increasing those factor. Oh, let me consider this, let me consider this, let me consider this. The factor keep increasing, and then the method also changes. So that is why we have one-way, two-way, three-way, four-way, five-way, six-way analysis of variance. I hope I'm clear with the one-way analysis of variance. Any question on that? Is it clear?
Yes.
Okay. Any question before we move on? Any question before we move on? Okay. Let's push it more. I think we're going to stop at Hanover tonight because we have chi-square already, but the way people are just calm down this time around, and then the number of people that we have here, we have just 48 out of 100 plus. Is not encouraging, but maybe it's because of the test and the like. Then they will get the recorded lecture. So sorry, ma. Please mute your mic. So let's move on. Now, let us check the hypothesis. How do we state hypothesis in F-test, which is the experiment of analysis of variance? How do we state our hypothesis? Now, the non-hypothesis, look at it. We have mu1 is equals to mu2 is equal to dot. Anytime you are seeing these three dots, it means hello.
Please, the network is breaking.
Please, can you hear me, or is it breaking for?
I think it's your network. It's not breaking.
Yeah, it's not breaking, sir.
Okay. Please check your network, please. Check your network. Now, if you look at this hypothesis, the non-hypothesis here, we have the mu1 is equals to mu2 is equal to three dots. That three dots means that it's continuum. And then we have the mu k. So irrespective of the number of group that you have, you cannot cover this k because the k continue. So if it is three groups that you have, it's going to be mu1 is equals to mu2 is equal to mu3. If it is four groups that you have mu1 is equal to mu2 is equal to mu3 is equal to mu4. If it is five groups that you have, we have mu1 is equal to mu2 is equal to mu3 is equal to mu4 is equal to mu5. So it depends on on your group. So this is how we state the non-hypothesis for the analysis of variance experiment, which is the F-test. Now, the alternative hypothesis will tell you it is not equal for at least one. That is, it's either the mu1 is not equals to mu2, but it's equals to mu3. But one thing about the analysis of variance is that once one out of the three, if it is three group that you are considering, once one of them is not equal to, let's say for instance, 1 is not equal to 2, it will reject everything. It will reject everything. That means that we're going to reject the non-hypothesis. Now, that is why the alternative hypothesis always state that, oh, it is not equal for at least one. It needs just one. Once one of the mean is not equal, that means that everything is condemned. So is that if you are taking your if you are accepting your non-hypothesis, that means that your mu1 must equals to mu2 and must equals to mu3. So can you see the mathematical method I wrote here for alternative hypothesis? Mu1 is not equals to the mu2, but it's equals to this and this. But once it is not equals to 1, that means that all of them will be what? Will be rejected. That is how we normally state the hypothesis in analysis of variance experiment. Any question? Can we move on?
Yes.
So I have a question.
Please go ahead.
This null hypothesis now, if we know now that when it comes out in the exam, it will certainly be 3 samples, 3 groups or 4 groups. Can we say this null hypothesis is mu1 is equals to mu2 is equals to mu3 and not include that
for 3
mu
groups? How
yes.
many groups?
For 3 groups.
For how many groups?
For 3
yes,
groups.
You are right. Non-hypothesis is right. For 3 groups is right.
Okay. So we don't need to put that extended to the mu k.
No. The one I'm giving now is the general.
Okay.
The one I'm giving is the general. So irrespective of the number of groups that you have, it will cover for it. Did you get it, please? Did you get it,
good,
please?
Sir. I'm good, sir. Thank you.
All right. Thank you. Now, the principle and procedure of analysis of variance. Here, I want you to just listen and you will get it. So I've broke it down to the extent that if you pick it, you can read it and get it. But let me explain it. Now, the variation in the sample mean between groups is compared to the variation within a group. Now, if the between the group variation is a lot higher than the within the group variation, then that suggests there are some differences among the population of interest, which invariably attempt to answer the following question. This one is just a scenario, it's just like a preamble before we enter the real work. Now look at the Roman figure 1. Are all of the observed value identical? It's not possible for us to have all the observation in each group to be equal. That's what I mean by that. They are not identical. Of course, no. So there is what? There is some variation in the data known as total variation. The total variation is what we call sum of square total. The total variation is called sum of square total. And then the sum of square total is expressed like in this equation 10. If you look at the equation 10, to get sum of square total is summation x minus x bar squared. If I expand this, I'm going to have summation x squared minus summation x all squared divided by n. This is the formula for getting sum of square total. Sum of square total is also referred to as total variation. Now, let's look at the next one, Roman figure 2. The Roman figure 2, are all of these sample mean identical? Again, the answer is no. You cannot have the same sample mean from the same sample mean for the whole group. Let's say I have group 1, group 2, group 3. If I calculate their mean, it can't be equal. No. So there is some variation between the group called between variation. You've heard about it, between variation between the group. We always hear between the group and within the group. So we have between the group. Between the group is another name called sum of square between. We call it SSB, sum of square between. We have sum of total, which is total variation. We have sum of square between, which is what? Between the group. Oh, from group 1 to group 2 to group 3. Now, this is the formula to get it. We have T square I divided by Ni. The T that you are seeing here is telling us the treatment. Oh, the treatment that I'm giving to each group. Like the one that we cited the other time, if we are giving drug to those that have diabetes, that drug, it is what we call the treatment, which is this T. Now, the I that you are seeing here means that I'm giving them from each group. Let's say I have group 1, I have group 2, I have group 3. So when I is equals to 1, that means that I'm giving the treatment to group 1, and then the N is equals to 1. So that means that those people in group 1. So now, when I is equals to 2, I move to group 2. When I is equals to 3, I move to group 3. That is the essence of this I that you are seeing here. Then we have what? The summation of the Ti squared over N. This is the what? The formula to get the variation between the group, which is the sum of square between the group. By the time we start solving question, and you will really understand this. Please take this like this first. So by the time we use example now, you will understand better. Now, there is last one that we call within the group. Within the group simply means that the sum of square within the group is equal to what? Sum of square total minus sum of square between the group. Immediately we have the sum of square total, then we have the sum of square between the group. By the time you find their difference, sum of square total minus sum of square between will give you sum of square within. Sum of square total minus sum of square between will give you sum of square within. Now, there is another one called degree of freedom. We have the degree of freedom for total, we have the degree of freedom for between the group, and then we have the degree of freedom for within the group. Now, if you want to get the degree of freedom for total, which is what total variation is, N minus 1. N is the total observation that you have from all the group. Let's say group 1, I have 10 observation. Group 2, I have 10 observation. Group 3, and I have 9 observation. So by the time I had by the time I had them together, I'm going to have 10 plus 10 plus 9. So that is my N. So by the time you subtract 1 from it, you are going to have what? The degree of freedom for what? Sum of square total. Now, N is the total number of observation. Now, the degree of freedom for between is K minus 1. K is the number of group that you have. Like for instance, the one we cited now, our K is 3 because we have 3 groups. So now to now get the degree of freedom for within the sum of square between the groups, so we're between sum of square between, we're going to have 3 minus 1, which is 2. So the degree of freedom for the 2 groups, for the 3 groups is what? 3 minus 1, which is 2. K is the number of groups. Now, the last one, which is the degree of freedom for sum of square within, is N minus K. Don't forget that N is the total observation that we have, and K is the number of group that we have. So N minus K will give you degree of freedom for within the group. So before we move down to the question to solve tonight, please ask your question.
Sorry.
The floor is open.
Okay. That degree of freedom total, I think is N minus K. I don't know. I try to be correct, sir. The degree of total.
The N minus K, yes. The degree of freedom for total is N minus 1. For the degree of freedom that you may mention now, N minus K is within the group. It's degree of freedom for within the group. Degree of freedom for between the group is K minus 1. While the degree of freedom for total is N minus 1. So these are the 3 things that we're going to be using to get our F test. Any question before we start solving question?
I have a question, sir.
Please go ahead.
Okay, the slides we were given by Dr. Folabi.
Okay.
Yes, when he was giving that SST, sum of squared total. He said it was summation Yij minus CF. So he now said that the CF is equals to G squared over N. So what I'm asking now is,
Okay.
when we're in the exam hall, which formula are we writing? Is it this one? He also mentioned this one also, but then the
He
first
mentioned this,
one
right?
was yes. So
Okay.
which one are
That
we
that
writing
GT
in the
that
exam hall?
wait, that GT that you are asking is called grand total.
Yes.
The grand total simply means that you will add all the observation, you will sum all the observation together. Then, if you look at this summation x means that sum all the observation. X are the observation that you have. Sum all the
Yes.
observation. So summation x that you are seeing here is grand total. We're still going to get to that place now when we start solving question. So what my oga gave you in the class is correct, and it's still the same thing as this.
Okay.
Did you get it?
Okay.
Very, very correct. Yeah.
All right. Thank you.
All right. Any question again before we solve this question? Okay, let's move. Please, I want us to listen to this question because I'm going to solve this. Then the next one, you will be the one to solve it and send me your solution. So please listen to it so that you can get it. Now, a researcher wishes to investigate the effect of exercise on obesity. Groups now. So immediately you know this is table groups. Forget about Z, forget about T. Exercise groups for weight reduction. So these people, they want to reduce weight because of their obese. Okay. So they enroll in what? In exercise group. Okay. The body mass index at the end of the exercise was subtracted from the body mass index at the beginning. Please and please don't go and think of PET test because you hear before and after, at the end and at the beginning. Some people may think of, oh, it is, they told us that before and after, beginning and the end. Remember that we have more than one perform the before and after, but in this case it's 3 groups, 3 samples. So please don't think of peer or dependent T test. It's very, very important. Once you see these 3 groups, forget about the family of T. We are now at the family of F. Okay, so beginning to obtain the reduction in the body mass index, the finding are showing in the table below. Now, before I show you the table below, the first question that they ask there is use the data to complete the table below. Okay, let's move to the table below. Now, look at this table. This is the data given to us. If you have that past question with you, it's there. 2020, 2021. Question 4 is, the whole question 4 is under F test, which is analysis of variance experiment. This is the data. We have the exercise group, we have upper, we have lower, and then we have upper and lower. Then we have a reduction in BMI for the study participant. Now, for those in upper group, we have this. Then for those in lower group, we have this. And then for those in upper and lower group, we have this. Now, the first thing that you have to compute is you are going to sum them. You first of all sum the upper. You will sum them row wise. So by the time you sum the upper here, you are going to have total at the end here. Sum them together. This for the upper. Look at my cursor here. The summation of upper is 30. 22.3 plus 3.1 plus 4 point this for plus this plus this plus this. By the time you sum them together, it should give you 30. Can you confirm that, please? Please confirm with your calculator, please. And tell me if it is correct. Are we still together?
Yes.
Yes, sir.
Okay. Please, I'm waiting for your answer.
Yes, sir. It is 30.
It's 30. Good, good. So we have the summation of upper to be 30. Now, the summation of lower, by the time you sum the lower, you are going to have 38.7. By the time you sum, the upper is 30. Good, great. Now, by the time you sum upper and lower together, you must have 74.4. By the time you do the summation of this, you will have this. Are we together now?
Yes.
Is there anybody typing calculator to confirm this answer for us? Anybody?
Yes, sir. It is 38.7.
Good. Okay. Now, if you look at the next one that I have after upper and lower, I have summation upper square. It means that I'm going to square this one after the other. 2.3 square plus, that's the meaning of summation, plus 3.1 square plus 4.2 square plus 2.3 square plus 2.7 square plus 2.9 square plus 3.1 square plus 8.28, sorry, plus 2.8 square plus 3.0 square plus 3.6 square. By the time you do that, we are going to have 92.94. Can you confirm that? And another person should start confirming the lower for me like that. Another person should start confirming the upper for me. So let's see. Put your hand on calculator, pen on paper. Let's start.
For the upper is 92.94. Upper square.
Good. Good. What about the lower? Anybody computing the lower? Anyone computing the lower for us?
I'm on it, sir.
Okay, good. And another person should be computing upper and lower for us. So let us confirm those answers that I have here. I have them inside my note already. I've worked it out, but type it and see it.
09. 158.09 for the lower.
For the lower is what?
158.09
For the which one?
for the lower.
For the lower, 158.
For the lower.
Yes.
Yes.
Yes, good. Okay. Can you see that it is not something that is hard? You are the one supplying me the answer now. That's great.
For the upper and lower, 571.42.
42. Good. Okay. Okay. We are good to go. Now, the person that asked that question the other time, that the GT, which is the grand total. Look at my GT grand total now. The summation of upper, that means that all the observations that I have here, plus the summation of lower, that means that all the observations that I have here, plus the summation of upper and lower, that means that all the observations that I have here will give me what we call the grand total. Will give me what we call what? Grand total. So that is 30 plus 38.7 plus 74.4. It will give me 143.1, which is called grand total. Did you get that?
Yes.
Are we still together?
Yes. So
Please,
Yes.
I want. Oh, okay, okay. Now that's for that. Now look at the next one. I find the summation of all the square upper that we have already. So that means that the summation of upper square plus the summation of lower square plus the summation of upper and lower square. So that means that I'm adding 92.94 plus 158.09 plus what? 571.42 together. So by the time you do the addition together, we are going to have 822.45. 822.45. By the time you do that. Are we together now?
Yes.
Yes, sir. Totality.
Okay. Now,
That again.
you said?
Please take that again, sir.
Which one should I take again? You specify.
The summation of the upper squared.
Okay. Now, with did you understand how we got summation upper square to be 92 here, 92.4? Can you see my screen?
Yes, sir. Yes, sir.
Okay. Now, all the upper square, lower square, and then upper and lower square, we are bringing them together. Call summation upper square plus summation lower square plus summation upper plus lower. The reason being this. Let me quickly go to the next slide. You will see the reason why. Now, if you see, this is the table given to us that they asked us to complete. They asked us to compute this table based on this data given to us. All those ones that you are seeing both, if you see it there, those are the ones that you are calling answer for me that we calculated. They were all empty. If you look at that past question I sent to you, they are all what? Empty. So we are the one that computed this ourselves. So the summation X here that you are seeing means that you will sum the summation of upper, the one that you have that you got 30. This 30 that you are seeing here is this. Can you see it? Hello?
Yes, sir.
Can you
Yes,
see that
sir.
30?
Yes,
So
sir. Yes, sir.
that is the summation of upper that you computed here. Now, the summation of lower that you computed here is this, 38.7. It was not given. We are the one that supplied it. So supplying all this is just half mark. This one half. So now you have what? 38.7. Now the last one that we computed is what? Is summation upper and lower. And then the summation upper and lower is 74.4. Now, if you look at what I call a grand total, look at it, which is what? 143.1 is the grand total. By the time you can do it, by the time you add all these observations together, it will give you this 143.1. It is called the grand total. That's why we have it here. Look at it. So by the time I add this plus this plus this, I have 143.1, which is my grand total. Now, another one that they gave us is summation x squared that they asked us to compute. We are not given. They only gave us this one, this last one. If you check that table from that question, you will see it's there. Now, by the time I find the summation of upper square that I asked you to compute the other time is what? Is 92.94, which is here. Look at it. Then the summation of lower or the lower square that I asked you to compute, which is 158.09, is here. It's not given. We are the one that computed this, so you have your mark for this. You have another half mark for this. Now look at upper and lower. It was not given. We are the one computed it, which is 571.42. So by the time you do that, you have your mark for that. Can you see it, please?
Yes.
Can you see my screen?
Yes, we can see it.
Yes, we
Okay,
can see
good.
it, sir.
Good. Now look at this now. They now ask us to compute this. Look at the summation of x squared. In this case, it's going to be summation of upper, sorry, if it is under upper, it's going to be summation of upper square minus the summation of x of upper, which is 30. Look at it. The summation of x for upper is 30. You put the 30 here, then we square it. Then divided by the what? The end. The end that you are dividing it here is the end of the upper only. Let's look at it. Let's look at it. Now look at this now. And I have what? The summation of what? Upper square minus the summation of upper all square divided by the number of observation for upper. That's why I put NU. The number of observation for upper Now we've computed our upper square to be 92.94, which we got from here, minus the summation of upper, we've computed it to be 30, which is here. Then the square is from our table. Look at the table. Let me show you the table. Look at the table given to us. The added square. Can you see the square? Can you see the square, please?
Yes, we can see.
Okay. So they added square to it. So that's why we are putting the square 30 square divided by how many observations that we have in upper. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 observations. That's why we are dividing it by 10. So by the time you do this, we are going to have 8.321. 8.321, which is what we have here. Where's 8.321? I'm coming. Oh, we computed for 8.321. We computed for lower. Sorry. Let's check the upper. Okay, sorry. The upper is 2.94. Can you see it? Please, can you see 2.94? So if you come back here, we have our what? 2.94. So by the time you complete this table, I think the mark is, let me check. For completion of this table, let me see. If the mark is there, I think the mark is 4 marks for the completion of that table. Is 4.
5 marks, sir.
Is it 5?
Yes, please.
It's 5 marks. So that is how you get your 5 marks. So it's just step by step. It's not something that is hard. Look at the way we started. From the observation given to us, we add them row-wise, and then we have them. From the observation given to us, we square them. This one square plus this one square plus this one square. We have this, the upper square. We have the lower square. We have this. From the observation given to us, we have what we call the grand total. By summing this plus this plus this, we have the grand total. From the observation given to us, we have the summation upper square plus the lower square plus the upper and lower square, which is this. Now, from the information given to us, we've computed the upper square. Then minus the summation of upper, we've computed the square divided by the number of observations for upper. So by the time we do that, we have this, we have this, we have this. Then we've completed the first table. This is the table of exercise. Any question on this?
Yes, I have a question.
Please go ahead.
Please go back to the previous slide.
Okay, sir. You mean this?
Yes. Okay. I've been given this in the exam hall now.
Yes.
Are we going to? This is on the question paper, the table. Are we going to draw it on our answer sheet before we now derive this thing?
No, you don't need that.
Draw the second one.
You don't need that.
Oh.
Is it that you, if you draw it, if you draw this on your answer booklet, that means that instead of showing you all this summation, you just be adding them. You create another column called total. So that means that you are going to have 30 as your total for this one.
Yeah.
Can you see? Then the next one, you are going to have this as your total. Then the next one, you are going to have this as your total. But if you don't draw the table, make sure you show this. You are going to show all these workings. Summation upper is equals to 30. Summation lower is equals to 38.7. Summation of upper and lower is equals to 74 point this. So you have to show it.
Okay, thank you.
So, but the table that they ask, wait, I'm coming. But the table that they ask you to complete, you must put it in your answer booklet.
Okay.
Okay, please, another question. Go ahead, please.
Okay. Just is likely to the question you just asked now. For the summation upper, you say it's 30. Are we going to put it arithmetically 2.3 plus 3 plus 0.1 plus? Can we do that?
That's very good question, man. Once you put, you have to put it, please. Because anybody can just look at another person and copy 30. Did you get it now? So showing it like that is a mark, but you don't need to write everything. What you need to do is that just put 2.3 plus 3.1 plus dot, three dots, then you move to the last one, plus 36, plus 33, plus 3.6.
Okay.
Did you get it?
Yes, sir. Yes, sir.
So any other question? Okay. So let's move. So are we clear with this table?
Yes, sir.
I'm not clear. Oh, just that it will draw you back. I'm not clear.
Which one you did not clear?
Even from that first one, sir, the lower and upper. I'm not clear. Just say maybe later I'll go and rewatch the video. I'm not clear. I'm just.
Okay.
Mm.
Okay, let me quickly take it again.
Oh, thank you, sir.
Now, you are given this data. If you I sent the question to the group. So if you look at that question, you are given this data. Now, you are given this table, but this table is the what is not complete. They've removed some things there. Now, they now ask us to use this data to complete this table first. That's the first question. Now, if you check that table, you will see summation x, you will see summation x squared, you will see this in that table. Now, to get your summation x for upper, that means that you are going to add all the data given under upper. That is what we have as summation upper. All the data that we have for upper, we added them together, we have 30. Now, to get, let's move on, to get for the lower, that means that you are going to add all the summation x, means that add all the observation that you have under the lower, which is what, which is this. By the time you add this together, you are going to have 38.7. Now, the last one is upper and lower. It means that all the observation that you have under upper and lower, you should sum them together. So by the time you do that, you are going to have 74.4. That one, is it clear, ma?
Yes, sir.
Okay. Now, the next one, if you check that table, is they ask us to find summation x squared. Now, under the upper, now, the upper will come in here. Upper will represent the x. So we are going to have summation upper square under the upper. For under the lower will take the place of x here. We are going to have summation lower square under the lower. And then under the upper and lower will take the position of x square here. So we are going to have summation of upper and lower. So by the time you do that, look at this, man. The summation of upper simply means that you are going to take this 2.3 square plus 3.1 square plus 4.2 square plus 2.3 square plus 2.7 square plus 2.9 square plus 3.1 square plus 2.8 square plus 3.0 square plus 3.6 square. By the time you do that, you will have what we call the summation of upper square, which is what we have here, which is this. By the time you do the same thing for the lower, you are going to have this. By the time you do this, by the time you do the same thing for the upper and lower, you are going to have this. So the addition of all of them is what we call as total. The addition of everything here is what we call total here. So now, even check that question again, you are having, they ask us to compute something like this. If you look at this, they ask you to compute this. So now, how do we compute this? Now, let's go back to our data. Now, in our data, remember that, let me show you this. Remember that summation x squared has been computed for upper, which is this. So we're going to have 92.94. Remember that summation x has also been computed for upper, which is 30. Now put it here. We're going to have what summation what? Sorry, we're going to have 92.94 here minus 30 square divided by how many observations do you have under upper? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you divide it by 10. So by the time you do that, we are going to have what we call 2.94 for upper, which is this. By the time you do the same thing for the lower, we are going to have 8.321. By the time you do the same thing for upper and lower, we are going to have what? We are going to have that. So is that one clear, please?
Yes, sir. Thank you, sir.
Please, you can still rewatch the audio so that you will still you understand it better. Now let's move on. I want us to finish this so that now the next one is use the complete table above to compute the analysis of variance table. That one is 6 marks. Now, all this one that you see, this one, all this one that are bold are the one that they've removed from that table. I've computed it. Now let's check the computation now. Are we together?
Yes.
Okay, just calm down. It's not something that is hard. Don't scared with all this formula. It's not hard. Now look at this. It's something that we've computed before. Now look at this. Remember that from the total variation sum of square total that I gave, I told us that it is summation x squared minus summation x all squared divided by n. Let me go back. Let me go back and show you. Look at it. Is this equation 10? Can you see it?
Yes, sir.
Another response, please. Can you see it?
Yes, sir.
Yes, sir.
Okay. Now, so we have the sum of square. So the total variation, which is sum of square total, is the summation of x squared minus the summation of x all squared divided by n. Now, let us come back. This is summation x. Let us go back to this place. Our summation x squared. Remember that for each one, we have the summation x squared. We have this for the upper, for the lower, for the upper and lower. By the time you add these three together, you will have this, which is the total of the addition of this, which is what we have here. Look at it. This is what we have here. Now, by the time you have this here, minus, let's go back, the summation x for all of them now. You know, we are considering total is this. Look at this guy plus this guy plus this guy. The upper plus the lower plus the upper and lower will give us 143.2. So the 143.2, we have it here. Look at it, 143.1. Then the square that you are seeing here is this. Then the 30 now, since we are considering the total, all of them, is now what all the observation that we have. By the time you count it, 10 for the upper, 10 for the lower, 10 for the upper and lower, it is what? It is 30. So by the time you put that one there, we are going to have this 822.45 minus 143.1 squared divided by 30. By the time you square it, you divide it by 30, you subtract it from here, we are going to have something like this. This is what we call sum of square total. Sum of square total. Any question on this? Hello, can you still hear me?
Yes, sir.
Yes, sir.
Yes, sir.
Sir, is it
Let us,
possible
we are
to
about
call
to,
it a night?
let us finish this and over. We are going to call it a night. We've not finished this question. Let us finish this question, then we'll call it a night. So we are going to continue from there tomorrow. Let us finish this question so that you can go over it tomorrow, then you'll be able to solve the question that I'm giving you now before we call it a night. Okay. So by the time you do this, we're going to have what we call the sum of square total. It is something that you can read and you understand. I've tried to break it down so that you can understand it. Now, the sum of square between, it simply means this divided by this. Now, if you go back to our table, it simply means that each of this, you are squaring each of this. You are squaring each of this is the treatment. You are, for the upper, you are going to square it. For the lower, divided by the number of observations that we have there, that will be 30 squared divided by the 10. This one will become 38.7 divided by 10. This one becomes 74.4 divided by 10. It's because they are all divided by 10. That's why I find the SCM. By the time you find the SCM, we're going to have 10. So now we're going to have 30 square plus 38.7 square plus 74.4 square divided by 10. So by the time you do that, then minus The grand total here is what our normal grand total is 143.1 square, then divided by total observation. By the time you do that, oh, we should have another answer here. By the time you do that, this should be a typo. So I'm going to correct this and send this tomorrow. The first one here, sum of square total, supposed to be 139.863. Then the sum of square treatment or sum of square between is 110.718. So by the time you do the subtraction, you are going to get 29.145. Although we've not finished, but I think let us call it a day because of people, so that they can go and rest and prepare for tomorrow. So we're going to continue from here tomorrow. Although I have a question and assignment, the practical question, but since we've not finished it, so I will hold on to tomorrow. So we're going to continue from here tomorrow. I'm going to take the F test over again so that we can understand. So thank you so much for your time. We really appreciate you. So at this point,
Thank you, sir.
let us call it.
Thank you,
Thank you,
sir.
sir.
All right.
Thank you, sir.
All right. Good night.
Thank you, sir.
Thank you, sir. Good night.